Our last two examples refer to problems that requires using laws of equivalences. If you still recall, we summarized the law of equivalences with our first 10 laws now, which are commutative laws, associative laws, and so on up to the absorption law. Okay, but we added some more laws of equivalences, those that involves conditional statements. So I also included that here. We have additional 4 laws of equivalences. The disjunctive form of P implies Q, which is P implies Q is equivalent to negation of P or Q, and then the negation of P implies Q, which is P and negation of Q. Then the contrapositive. Okay, you remember the contrapositive is equivalent actually to the conditional statement. Then the biconditional, no? Which is the conjunction of P implies Q and Q implies P. So we will refer to this to determine or to answer these two questions. Okay. First question says, show that P implies Q or R is equivalent to P and negation of Q implies R. We can actually answer this question by constructing a truth table, right? But I will solve this using the laws of equivalence. Okay. Let's start with the left-hand side. So our objective here is to put series of statements which is equivalent to this, okay, but every step must be justified by a particular law of equivalence until such time when we obtain the right hand side, okay, of the expression. Now what do you think is the first statement that is equivalent to this one? We can actually first use disjunctive form, no? Disjunctive form of this, meaning let us convert the implication to disjunctive form, which is according to number 11, the disjunctive form of P implies Q is negation of P or Q. Okay, so that means that this will become negation of P, then or Q or R. So this is the first, this is the second. The disjunctive form says that you negate the first, then the implication is replaced by or, then just write down the second. Okay. Then after that, to take note that our objective is to obtain this one. That means that we should be able to regroup this, right? Okay. The parenthesis here should be placed now with P and Q. But are we allowed to do that? Yeah, we're actually allowed to do that because of the associative law number 2, okay, which says that you can regroup as long as they have the same logical connective. Okay, so this means that we can write this as negation of P or Q, then or R. By the way, it is important to indicate here the law of equivalence that we used. First, we have the disjunctive form. Okay, well, this one is associative laws, and Okay, our main objective, take note, is that we should be able to write this as P and negation of Q implies R. But how can we write it into that form? Well, first, I think what you can do here is to make use of the disjunctive form, if you remember. Disjunctive form, or if you don't want to use the disjunctive form, then you can start with writing using the De Morgans to put the negation outside. Okay, maybe we do that. Okay, the De Morgans says that if we put the negation outside, then this one will become P, and this one will become N, but this one will become negation of Q, right? Because if you distribute back the negation, that will be negation of P, or negation of the negation of Q, which is Q. And then we have R. And then we used here the De Morgan's laws, and it consists now of two parts actually, no? Because this is group, so this is the first part and this is the second part. Take note that our objective is to replace this with implication. So how can we do that? By using the disjunctive form, because according to the disjunctive form, if you have negation of P or Q, it will become P. Look at that, the negation will be removed. Okay, P then implies Q. So that's what we're going to do here. Okay, the negation will be removed, so you have P and negation of Q. Then the or will be replaced. The or will be replaced by the implication. So implies R. Okay. We're using here the disjunctive form. Okay. So we're able to show that P implies Q or R is equivalent to P, and negation of Q implies R. Next example, okay, this will be our last example. Show that the negation of P or Q implies negation of P is a tautology. Actually, I'm sorry, this is not actually a tautology, this is a contradiction. And this is a contradiction. Okay, let's use the laws of equivalence to show that this is a contradiction. Let's convert this into something wherein that the statement that we'll write here, series of statements that we write here, will lead us to conclude that this is a tautology. Okay. Sige, I would prefer simplifying first the expression inside, or you can also choose to distribute the negation. Maybe we'll do that. Okay, let's distribute the negation. Okay, we will apply the De Morgans now. So negation, using the De Morgans, we have negation of P, then the or will become and then the negation of Q implies negation of P. The law of equivalence we use is the De Morgans. Okay. And then after that, we cannot distribute the negation here unless this is written first in disjunctive form. So let's write this in disjunctive form. In disjunctive form, remember, you have P implies Q. The disjunctive form is negation of P or Q. So this will become negation of Q or negation of P. The reason for this step is the disjunctive form. And then after that, we will apply De Morgans, of course, in this, right? We cannot distribute the negation. So we have negation of P, and so we distribute that negation of the negation of Q is Q. The OR will become AND. The negation of P is P. We use the De Morgan's law. Next step. We want to show that this is a tautology, but we can only show that this is a tautology, or a contradiction, if this P will be paired with negation of P. But how can we do that? First, we will try to move P here, move P here and Q here. Okay, we can do that only by using what particular law of equivalence. Okay, we are actually commuting, no? So that's commutative laws. Okay, you can interchange the position. So this is commutative laws, and then next is, so we can now put together negation of P and P. Why can we do that? Because they have the same connective. But having the same connective does not always allow you to put together or to do associative, no? Because if the connective is implication, you cannot do that. Okay, that's allowed only for and or. Okay, so the law here is associative laws. And what is negation of P and P? Negation of P and P. Let's look. It's here, right? P and negation of P. That's actually a contradiction. Okay, contradiction. So that's a contradiction. And Q. And what is that? That's negation loss. But what is contradiction and Q? Contradiction and Q, where is that? Here. Contradiction and P, or contradiction and Q, is also a contradiction, and it's according to universal bound laws. So we have proven that this is a contradiction.